So if everyone would go ahead and pay attention to the big screen. We've got just a couple of objectives left in this chapter, which really start just with these last two. So we literally have a couple left. And the first one is creating your own exception class. And so the first thing is, why in the world would you create your own exception class? And the answer to that is, there are, like this book says, there's 100+ built-in exception classes that handle the common scenarios where exceptions would be thrown in C#. And, those handle most scenarios. But what they don't handle is your specific company's business logic that could cause a problem. Okay, and every company is different. Okay, that something would be considered an exception. So, kind of going back to, well, what is an exception? Well, an exception is something that would cause your program to crash. That's how we defined it originally, but a little bit, I guess, less extreme version of that. An exception could be defined as an error that happens as an exception to the norm. Okay, so an exception could be defined a little bit differently as an error that happens as an exception to the norm, meaning normally this error does not occur, but exceptionally once in a while it does. Okay, now what is once in a while? The most concrete definition I saw was if this error is expected to happen about 1/3 of the time or less. Okay, that's about the most concrete definition I've ever read about when something should be considered an exception. Okay, now if it happens exceptionally, that's when you could generate your own exception class. That's an error that happens, again, about 1/3 of the time or less. Otherwise, if it happens as part of the norm, if it's a normal error that happens, again, 2/3 of the time or more, okay, then you could use the traditional error handling with the ifs and the loops that we discussed way back in the first video. We discussed traditional error handling, comparing it to the object-oriented exception handling. Okay. Now, one of the things I didn't really spell out too well in that video is if either one could handle it, what's the benefit of exception handling over traditional error handling? Because we said exception handling, really all we said was it's an object-oriented approach. It keeps your program from crashing. But what if it's just an error? If it's just an error that's happening and it's not crashing your program, you might think traditional ifs and traditional error handling would always be the solution. But one thing, and the book mentions this in one paragraph, one thing that's worth realizing is that the exception handling, the object-oriented approach, allows you to handle the error code in one specific spot. Okay, that's a benefit. Okay, the error code is all handled in that catch block. So when you see a catch block, you recognize that as the error code. Okay, whereas we have an if and an else and you've got loops and things like that, your error code is handled within all your normal code. Okay, so realize that's kind of the benefit of the object-oriented approach. Whereas it's a little bit slower Most machines today, you're not even going to notice, but that's a benefit. So kind of going back to where this all started, wrapping this back in, there are times in business where an error would occur and they want the benefit of handling the error all in one area of their code, all within the catch block. So they say, you know what? Our business at Rankin, and I'll just make this up, our business does not, you know, so, nah, I'm not even going to bring that up. Our business does not enroll elves, whatever. Who cares? That's a business rule. If it's an elf, we don't like you here. Okay, so whatever. You see what I'm saying? Now the book gives a real life example, right? The book is like, okay, if a bank balance goes below zero, okay, that's a business rule. Okay, that's a real business rule. I'm trying to give Rankin a business rule, so you know maybe if a student's GPA, here's what we'll do. This is much better because I couldn't think of one, so I made something stupid up. If a student's GPA drops below a 2.0, put them on academic probation. Okay, so that'll be the code example that where we make an exception class for a student's GPA. Okay, so that's our example. We're going to worry about a student's GPA, and if they drop below a 2.0, we want to be able to handle that a certain way, and in our code, we're going to want to handle it in try-catch blocks. Okay, so the first thing to do here, we're making our own exception class, because we need to make a class, and it's not, as far as the code goes, it's not very complex. And I'll just make the class called student. Did I really? Wow. Okay, let's try this again. Studnet. Do a little refactoring here, right? Student. I'll make a instance field. And then I'll make a property. Okay, so this is our student class, but this is not our exception class. An exception class is going to be separate from this. So I'm going to add another class, and I'll call this GPA exception. Now the first thing is GPA exception gets to inherit from exception. So that's, you want to make your own exception class? There it is. That's as difficult as it is, right? We're gonna make our own exception class. It's the GPA exception. We're not worrying about how it's thrown or anything about here. We'll make a constructor for this. And we'll pass up to the base constructor. We could pass up the message for the property, the exception objects property, the message property. What will it say when this exception is thrown? What will the message property say? You put that right here. You put that in the quotes in the string, and our message will say GPA is too low. Place student on academic probation. Okay, and so this is going to be the message property that is displayed in our catch block for our exception. Now in our student class, this is where we throw the exception if the GPA is too low. So inside of our set block, before we set the GPA, oops, I goofed. This has to be setting the field equal to the value, not the property equal to the value. Did you guys see that mistake?
Yeah.
Don't do that. Don't make that mistake. Set the field equal to the value. Now what we need to do is we need to test that value. Before we do this assignment, we need to test the value to determine if an exception should be thrown. So what we're going to do here, if the value that's passed in is below a 2.0, there's a shorthand for this that I like. We're just going to say throw new GPA exception, calling the no-arg constructor. The no-arg constructor is going to have this message passed up to the parent constructor by default. The parent constructor being exception. So calling the no-arg constructor. Now notice we throw an exception. If it's not caught, this will crash our program. And we can demonstrate that here. Let me collapse here. These are other methods that we wrote yesterday. So we'll create a student object, and we'll go to set the GPA. We'll set it to too low, and just run the program. And there you have it. Unhandled exception, a GPA exception. GPA is too low, and this is essentially the program has crashed, and you could see demo has stopped working. Okay, but at this point, all we have to do, if we don't want it to crash, right, is handle our exception. And then here's the benefit. Now our error code is all handled in this catch block. And we want to catch a GPA exception. And let's do a console.writeLine ex.message. And now we get a little bit friendlier error message to the user, and the program would continue on. It wouldn't crash, and it would just continue on and run as normal. Okay, so that's a fairly basic example of creating your own exception, but it demonstrates everything. It demonstrates creating the class. It demonstrates instantiating the class and handling it inside of your main. Now, the last chunk that we're going to discuss is this idea of rethrowing an exception. And it ties into our video yesterday where we did exception bubbling. And in exception bubbling, remember we had an exception thrown in method C, and it could bubble all the way up to main. You could catch it in C, you could catch it in B, you could catch it in A, or you could catch it in main. And that would work. Well, sometimes you might have an exception be caught where you really don't want it to be caught. It might be another catch block catching your exception in a method that you don't want it to be handled in that method. You want it to be handled in another method. You don't want it to be handled in method B, but method B happened to catch it because it had a catch block there for another purpose. And that catch block happened to catch it. So instead of handling it in method B where you don't want to handle it, okay, you could rethrow the exception. And that's done simply with the keyword throw. And so let me kind of go back here to our demonstration yesterday. Or if we remember right, we just had a call to method A. I commented it out. I'm going to recall my method A. If we remember, method A called method B, B then called C, and then C had an exception. So if we run this and just says method C is running, what is the denominator? 0. We have our unhandled exception. Program crashes. Let's say for whatever reason we had a try catch here, and the catch was a general catch like exception EX. So now the exception was caught in B, but we don't want the exception to be caught in B. We want it to bubble up to main. So it's done simply with the keyword throw. That will instead of the exception being caught at that point, this exception will continue to bubble up the call stack. That's really the theory, and I don't know that we'll be having any labs where you need that. You might. I don't think so, but it is a keyword that's there for you to use. Should you come across it, should you see it, realize what it's doing.
So that just always takes to the top of the call stack.
Well, it takes it up to the next method. So now it would go back up to method A, and it would see if method A could catch it. And then here what we'll do is we'll catch it again. We'll catch it here. And just to demonstrate this, I'll say console.writeLine recaught in main. Just to demonstrate that it did get rethrown, I'll start without debugging. Throw the exception in C. It's caught in B, and then it's recaught in main. And then it just continued on to show the other example from before. Okay, so it's not anything that, again, that I don't think we're going to be using too much in the class, but it is a keyword. It is there for you to use, and it is there for others to use, so it's worth being familiar with. Okay, so hey, I kept my promise. It was about a 20-minute video, so we'll stop it here, and you guys got lab time.